Hello everyone, today we're going to explain how to configure VLAN functionality on Cisco devices. As for VLANs, I'm sure many of you have heard of them. They're called Virtual Local Area Networks. Essentially what we do here is segment and isolate our local area network, dividing it into different LANs. This way, different VLANs cannot communicate with each other, which helps ensure certain security aspects within our network and also prevents broadcast storms. So the first step here is definitely to create our VLANs. In this process, we first need to access the device, for example, by entering Enable and then go into the configuration mode. Once we're in the configuration view, we can create VLANs such as VLAN 10 or VLAN 20. This part is actually very simple. If you need VLAN 10, just create VLAN for 10. If you need VLAN 20, just create VLAN 20. After creating them, let's consider a scenario. Suppose PC1 is assigned to VLAN 10, PC2 is assigned to VLAN 20, and as for PC3, it belongs to both VLAN 10 and VLAN 20. In the future, we want devices in VLAN 10 to be able to communicate with each other, but devices in VLAN 20 should not be able to communicate with each other. For example, here it has a VLAN 10 tag, and in this process, this side is VLAN.20. On the left side as well, we can see that the device on the left is also set to VLAN 10. Here, we also set it to VLAN 20, so they are assigned to VLAN 10 and VLAN 20 respectively. So in the future, when we communicate, 10s and 10s can communicate, but 20 and 20 cannot communicate. Devices in different VLANs, for example VLAN 10 and VLAN 20, cannot communicate with each other. Now, in this process, we first configure the VLANs. After configuring them on switch 1, we also need to configure them on switch 2, and the process is the same. Enter privilege mode, then go into configuration mode, and in configuration mode, create VLAN 10, as well as VLAN 20. After creating them, next we need to change the type of the interface. Here, if I am connecting end devices in the future, such as our computers, printers, servers, or cameras, they will use access mode. When receiving, I am responsible for adding the tag, and when sending, I am responsible for removing or stripping the tag. So here, let's start configuring from the very beginning. In this process, if we need to enter the interface, we use Interface 101. After entering the interface, we then make a series of changes to its type, using switch port mode, access, to change it to access mode. This is called access mode. Because right now we're connecting a computer, after connecting in this process, we need to assign this interface to the corresponding VLAN. Here we use the command switch on port, access, VLAN 10. With this, our interface 0 is configured. Our interface 1 will be assigned to VLAN 20 in the future. Here, the steps are the same. First, change the interface type to access, and then assign it to the corresponding VLAN. After assigning it to access, VLAN 20, we can check the configuration. So how do we check it? Here we can use the command show VLAN top brief to check a summary of the VLAN status. Now here we can see that interfaces 0.0 and 0.1 no longer belong to the default VLAN 1. Now, since this is an access port, we also need to make the corresponding configuration on SW 2. Similarly, we go to interface 1000. Then under the interface, we set the switch. Port mode to access type, access MOX. Then we assign its interface to a VLAN, which is called switch access VLAN 10, and then we enter the E01 interface. During this process, it's essentially the same as before. We need to carefully carry out the corresponding configuration here. Switch mode, access, and in this process, we also configure switch access VLAN 20 accordingly. After the configuration is complete, we also perform the corresponding check, which is called Chinli Guangmi Wankingli Counterquality Do. Show on the VLAN call brief. In this process, we can see inside that our E00 and E01 have also been assigned to their corresponding interfaces. Now let's check whether PC1 can still access PC2. Here, if PC1's IP address is 192.168.1.10 and PC2's IP address is 192.168.1.11 and both of their subnet masks are 255.255.255.0, then by default, since they are on the same subnet, they should be able to communicate directly. But in this process, let's see if we can ping 192.168.1.11. Can they communicate? In this case, they can't communicate because the two are not in the same VLAN. So now, if we can't communicate directly, can devices within the same VLAN communicate with each other? For example, let's say PCIE wants to access PC3. PCIE's address is 1.10 and PC3's is 1.12. So let's check if that's possible. Again, we'll use PCIE here and try to ping 192.168.1.12 to see if it works. Then the result here doesn't make sense either. Why can't they communicate? Because in this process, there is something we need to understand. Right now, we haven't configured the interfaces of the devices in between. Here, if I set it to 10 and later, when I send data from this interface, by default, its VLAN is VLAN 1, so it won't let me pass through. But can we configure this as an access interface? No, we can't, because an access interface can only serve one VLAN. So this interface can either be set to 10 or it can be set to 20. If we configure it as 10, then 10 can communicate with 10, but 20 cannot communicate with 20. If we configure it as 20, then 20 can communicate with 20, but 10 cannot communicate with 10. So in this process, we can't use access interfaces. Instead, we need to use trunk interfaces. Now, regarding the trunk interface in this process, first let's configure the trunk mode. We need to enter the interface, interface 102, and then under this interface use switch trunk to change its tag to .1Q tagging. Also modify its mode here by setting it to mode trunk. After changing the mode, we then set its allowed VLAN list. This means that in the future, when data with VLAN 10 and VLAN 20 tags arrives, we will keep the tags and let the data carry them to the switch on the second floor. Once it reaches the second floor switch, it can use the corresponding tags to forward the data accordingly. Now here, this is the device on our SW2. If that's the case, the devices on our SW1 are set up in the same way. For interface 102, first we need to change its trunk tagging mode here and set it to .1Q. After switching to .1Q, we then change its interface mode to trunk mode. Switch port mode trunk. After setting it to trunk mode, we configure the allowed VLAN list in this process. Switch port trunk allow VLAN 10, 20. Now, after we finish configuring the trunk in this process, let's go back to the PCIe and try to ping again. Ping 192.168.1.12. At this point, communication should work normally. In other words, devices in the same VLAN can communicate, but those in different VLANs cannot. If in the future you want to learn more about networking, or if you're interested in Cisco or Huawei technologies, feel free to message me privately or leave a comment below the video for technical discussions.